All right, so we're looking at 10.6 today, functions. And where's 154? There we go. Yeah, so we talked about that here. We did the definition last class. And make sure you guys had this from last class, right? Definition of relation. Somebody can chime in. You know, anybody target this from last class?
Mm-hmm.
Yeah, we got that.
Okay, just making sure. Got this part.
Yeah, we got that.
All right. Definition of function. Tell me if I'm showing you something that you haven't seen.
Did we get that? I don't think we got the rest of this.
Okay.
Uh,
Oh yeah, we did. We did.
yeah, we did.
We did.
So you got this part too.
We stopped around this part.
Yeah, we stopped after B.
After B, and so you got this part too, right?
No.
Yes.
Wait.
Yeah, we stopped right after here.
Okay.
Right here.
So, Mr. Vincent, did you get that?
I did not.
Okay, you want to copy that real quick? And then, because this was after we did that last terminational one, you know, last few conclusions about our functions. So good, we're in a good place. And then what we'll do is do function notation, and then that'll be it for 10.6. I already talked about domain, so I can go. Yeah, we got like 2 things to talk about left, and then we'll be done with 10.6. So let me know once you finish copying that, and then we'll go to the next page.
Oh my gosh. Stop doing that.
All right, are we good to go?
Yeah.
All right, cool. All right, so let's go back to 160 as a matter of fact. Let's see if they got it in here. Nope. All right. So let's look at function notation to close this out. All right, so function notation is y equal to f of x. So once they've established, you know, function notation or introduced function notation, they expect you to hold on to it. And what I mean by that is that within a problem or explanation, they could exchange or change y and f of x and expect you to know and be okay with it. So in other words, when you look at y equal to 2x, you can rewrite that as f of x is equal to 2x, and that still be the same thing and represent the same thing. And I think I mentioned that represents f of x. That's why I wrote right there. Just like if I had, this will represent g of t. So we're using different letters other than f and x. That would still be function notation. That would just be g of t. All right. So what does it mean to have function notation? Why would you use it? Well, you could be in the position in which it would say something like find f of 3. And even if it didn't say find, if you saw f of 3 and you wanted to know what f of 3 was, you would know that you would take 3 and plug it into your function where you see x. So to find f of 3, we would do 2 times 3 plus 1. I'm trying to give you a chance, hopefully. Nobody else is copying, right? If I scroll up, everybody good? Like that. So calculate, and that's 7. And then also what that means is if you have f of 3 is equal to 7, that means you are saying that your ordered pair was 3, 7. In other words, you plugged in x, which was 3, and you got out 7. So function notations allow you to give instructions without saying pretty much any words.
So basically, when we're doing this, we're looking for ordered pair as the answer.
Well, no, if they just say find f of 3, then 7 would be your answer.
Okay.
Yeah, but I was just saying that within that notation right here, f of 3 is equal to 7. That's the same thing as saying that your ordered pair is 3, 7.
Okay.
Mm-hmm. But yeah, they'll let you know, and if they wanted to answer an ordered pair, they will form it in such a way that, it will be evident that they want an ordered pair. Yep. Right. All right, so given that g of x is equal to x squared minus 5x plus 7, find g of 0 and g of negative 2. So we're looking at a first, g of 0, it's just plugging in 0, where you see x. 0 squared is 0, minus 5 times 0, which is 0, plus 7. Oh, they're getting 7 again, right, for a result. But that would be your answer. Oh, and this directions actually it says find the following, then write the corresponding order pairs. So just be prepared. Just watch the directions, because then it also say in this one, write the corresponding order pair. And so the last book didn't even ask for that. So remember, we were doing this pilot course. So this book actually says, give the order pair as well. So you should be able to give either or. So when you solve down, you get 7. But then if they want the order pair, know that you plugged in 0 and got out 7. So the order pair should be 0, 7. And then do the same thing for negative 2. So negative 2 squared, the parentheses around that negative, so that's going to be negative 2 times negative 2, which would be a positive 4. Negative 5 times negative 2 is a positive 10. And that'll be 21. All right. Questions? Any questions? All right. Last thing in this section is find the domain. And they give us, say find the domain range. Okay. And they give us this in two different types of forms. So the first type is they give us an equation and ask us to find the domain. The second type, they actually give us a graph and ask us to find the domain range. So let's look at the first type first when they give us an equation. So okay, let me do this. And I probably should have put a g of x or f of x in front of this. All right, so when we want us to find the domain, we want to know all of the values that can be used in the equation. And let's say for x. Or you can look at it and say all values can be plugged in for x. So when you talk about your domain, you want to know what are all the values that I can use. So there must be something in your equation that stops you from using certain equations, certain values. So in other words, look for the values you cannot use first. All right. Matter of fact, I think I'll change it to a different color. All right. So the way we'll be able to find this out is that you want to look for the values that you cannot use first. That will be the easiest way to establish what you can use. Because what you can use will always go pretty much to an infinite amount or infinitely many values. So you want to look at what can I not use? What will make my function undefined? So when we look at this scenario, and that's why I changed colors on that. See, a general premise is look for the values you cannot use. But specifically, when we look at this equation, a fraction cannot have a zero in its denominator, cannot have zero in its denominator. So you want to know, when is the denominator zero? So that's where you should be looking at. When is this denominator going to be zero? All right, make sure you got notes before I look to do this. Scroll up. All right, so when we're looking at a fraction or a rational expression, those are used interchangeably, so I just want to get you used to the terminology. Rational expression and fraction are the same. So let's see. Everybody can hear me, right? I saw a message that said my internet was unstable. Everybody good?
Yes. We can hear
Okay,
you.
cool. All right, it says to find the domain of a rational expression, or in other words, a fraction, set the denominator equal to zero and solve. So I said all of this to set you up for other, just the general thought process you should have when trying to find the domain. Once again, the domain is going to be all the values that can be used in the equation for x. So that means all the values that can be plugged in for x. Probably could have wrote that better. Plugged in for x. So you want to look for the values that you cannot use first, because that would be the easiest way to determine what you can use. So now when we're looking at this fraction, a fraction cannot have zero in its denominator. That gives us undefined. So when is our denominator zero? In order to find that out, we will set the denominator equal to zero and solve for x. So x plus 5 equal to 0. Subtract 5 from both sides. X is equal to negative 5. All right. So this is when your denominator is equal to 0, when x is equal to negative 5. Negative 5. So that's the value that cannot be used. But I can use everything else. So everything else can be used.
Wait, I'm sorry, Professor.
Mhm.
How did you get x equals -5 from x plus 5 equals 0?
Subtract 5 from both sides.
Oh, okay.
Yep. So you just go back to using how we solved equations.
Okay.
Yep. All right. Everybody good with that before we finish it off? Good question. All right. So that means our domain is going to go from negative infinity to negative 5. use parentheses because we can't use that -5. We can get as close to -5 as possible, but we cannot use it. And then we go from -5 to positive infinity. So we can use everything after 5, we can use everything before 5, we just can't use the 5. And you know, so whenever you have a fraction, whenever you have that type of setup, all you have to do is set the denominator equal to 0, solve it for your variable, and that will be your domain. But that will tell you what you cannot use, and then you'll be able to set up your domain. I'll say it like that. That'll be a better way of saying that. That tells you what you cannot use. Questions on that one before we look at another one? All right. So another one, they didn't give you that many. Was for what I see, you're talking about a fraction type, and then one like this. So here we have g of x is equal to 3x minus 1. All right. So now you have to ask yourself, same type of thought process that we had before. What would make this one find? Let me see. What values? Let me say it better. I'll say it better like this. Are there values of x? So that's what you always want to ask yourself. Are there values of x that you cannot use? Another way of looking at it is there something I can plug in for x to make the equation undefined? All right. So in this case, all right. So in this case, the answer is no, there is not a value for x that will make this equation undefined. So when we go back to what we have, talking about 3x minus 1, there is no denominator, and you guys are not going to have to deal with radicals and, you know, trying to find your domain with radicals. So you can't plug anything in here that will make it undefined. I mean, it's just a straight line when you look at the graph. You know, every time you plug in a value, you'll be able to get another value out. If you plug in 1, 3 times 1 is 3, minus 1 is 2. Plug in 100, 3 times 100 is 300, minus 1 is 299. No matter what you plug in for x, you will always be able to get a value. Once again, if you go back to our first example, that was 1 over x plus 5. If I plug in -5 for x, I get 0 in my denominator. That is undefined. There's nothing for this that will make or create an undefined scenario. So whenever you have just a regular equation, your domain is going to be negative infinity to positive infinity. That just means you can use all values. All values can be used. Questions on that? Questions. So there has to be some type of pre-existing condition that will cause you to think about what you cannot use. Once again, when you have fractions, you cannot have 0 in your denominator. So you want to know, okay, what will create a 0 in my denominator? That's why you take the denominator, set it equal to 0, and solve for x. When you talk about just a regular linear equation, like we have here, there's nothing that's pre-existing before they gave you this equation that you say, okay, when I have a linear equation, something will be undefined. Just like I said, you guys aren't going to deal with it in this class, but when you go further, if you have a radical square root, well, you cannot take the square root of a negative number. So that would be a pre-existing condition that say, okay, when am I going to get negative numbers under my radical? Like I said, I didn't see any of those in your homework problems, so you shouldn't get any. If you do see anything, let me know, and then we will talk about it. But I don't see anything in the book. But there has to be a pre-existing condition before they give you this equation that makes you say, okay, if I have this, this will be undefined, or I cannot use these type of values. And so those are the two scenarios I see here. And then, like I said, just go back to your thoughts of if I plug in anything, can I get a value out? If there's a reason for me to not get a value when I plug it in. And yeah. Before we look at these graphs, questions on those two examples? All right, so here it says find the domain and range. They give us this graph. Don't forget domain, x values. And we're talking about left to right. Your range, let's make it another color. Y values. And we're talking about down to up. So, and the reason why I say it in that way, you're always going to do your lower value first and then your greater value. So when you look at your x values, you're going from left to right. When you're looking at your y values, you're going from down to up, lower value to higher value. All right, so when we look at our domain, I wonder if I should have made that open circle. Let me see if y'all see any open circles before I keep going. Okay, so they don't give you any open circles. All right, so we don't have to worry about it. All right, so your domain going from left to right is going to go from -3 to 4, and you would use bracket because those are closed circles. They didn't give you any open circles, but if you were to see any open circles, then you would use a parentheses. So I can write that note, bracket. So I'm talking about right here, you know, both of your points were closed circles. So both of your endpoints. All right, and then the range is going from -1 up to 5. All right, questions on that before we look at B? Make sure we're okay. Oh, it's strong. Let's see, try one time. Yeah, I could have did that better. All right, so here we have a parabola. Same thought process as the one before it, looking for the domain and range. Remember, your domain is going from left to right, range is going down to up. Now, when we look at our domain, we're going from left to right. This will continue to go, you know, to the right and to the left to infinity. You know, it's going to keep getting wider and wider as you continue to go up. It'll continue to get wider and wider. So your domain is actually going to be -infinity to infinity. Don't forget, parentheses are always on your infinity signs. Now your range, our lowest value in our range is going to be -2. Remember your range or your y value, so we're looking at -2. This is our lowest value, and that is -2, and then it's going to go up to infinity. All right. Questions? Any questions?
You can just hold that right there.
Mm-hmm. So that closes out chapter 10 for us. Next class, I'll open up the floor for you guys to ask whatever questions you want to ask, whether it be out of chapter 10 or the first chapter was chapter 9, I believe. Chapter 10 or chapter 9. Was it 9540? That was a mixture of sections. But that first block of homework assignments or chapter 10, you can ask whatever questions you want. I don't have to do anything new as far as material is concerned. You know, it'll just be a floor for you guys to ask whatever questions you may want to ask in preparation for your test. Don't forget that, you know, you would set those up with Mr. Davis, shooting him that email. You know, it's J.L. Davis. Oh,
We only had one test so far, right, Professor?
yes. And so, yes, that's absolutely correct. And we're prepping right now for the second one.
All right.
Yeah. And don't forget, you take that on your own time. We use the class time to do new material and discuss whatever it is you guys, if you have questions on anything. So that's why next class, try to reserve that for whatever questions you may generate over the weekend.
All right.
hmm Any questions on anything before we really close out today, unless you have questions.
No, sir.
All right,
I
all
have
right.
some homework questions for you next class though. So
Okay, sounds
yeah,
good.
work through my
Sounds good. All right. So, you guys have a great weekend. Be safe. Like I said, bring those questions on next class, and we'll knock them out. I won't even ask where you got them from. You could have saw them on the test and be like, you know what, I want to see him do this. So that's fine. Let's get those questions out of there so you can be successful when you go about taking your test. So
Okay.
outside of that, you guys have a great weekend. Be safe, and I'll see you next class.
All right. Thank you, Professor. You do the same.
Thank you. Appreciate it.